Assalamualaikum. In this section, we discuss about the plant chromatography, and this is our last part of the liquid chromatography. After the completion of the chromatography, I will make a short video regarding chromatography, in which we discuss every important point of our lectures. Now we discuss plant chromatography. There's different types of plant chromatography. Plants means at any surface. For example, we say paper chromatography or thin layer chromatography. Paper chromatography, a piece of paper in we use as a suppression technique. A thin layer chromatography is that a glass or a plastic or some sports in which we apply a stationary phase, and it's used as a chromatography rather than we use a column chromatography. Now in plant chromatography, we discuss two types of chromatography: paper chromatography and thin layer chromatography. These two type of chromatography are working are similar. Now we discuss about the paper chromatography. There are different types of paper chromatography, sometimes ascending, descending, radicals chromatography. Now if we discuss about the paper chromatography, a paper chromatography means we use a paper such as a filter paper or a cellulose paper as a stationary phase in a suitable size, for example 20 to 30 centimeter long or 3 to 5 centimeter wide. We use as a stationary phase, and solvent is used for the mobile phase. If we discuss about the working of it, we discuss from here. This is imagine that this is a paper, and we take a concentrated spot on the paper on the edge of at one side. After that, we place our paper on a chromatographic jar. A chromatographic jar, that is our mobile phase is placed in it, but we care that our drops or our mixture of the drops is not dip in the mobile phase, that is above the mobile phase. After after the replace of the paper, we close our container. Because if our mobile phase is volatile, that is evaporator. That's why we must contain a vacuum to close a container. Our mobile phase flow through the stationary phase through capillary action, and our component of the mixture is separated. After that, our 3 by 4 distance cover. Now we open it and replace a paper and draw a solvent front line. What is the why we line a solvent front line, and what is its requirement? A solvent front line is help to determine the our component that is not to go too much through the stationary phase. That's factor we discussed in RF value. After that, we viscolize the paper in different detectors. For example, if our component is detect in UV lamp, we use a UV lamp to detect it, and spot a circle that show in the UV lamp that is dark. If we can't show, we spray some iodine spray that viscolize our component. After that, we viscolize it. We determine retention factor. Retention factor help to determine the polarity of our compound, that is polar or non-polar. The formula of retention factor is the distance traveled by a solvent front divided by distance traveled by our component. Distance traveled by a component divided by distance traveled by solvent front. Now, for example, from there to there, that is the solvent front measurement. But from there to their baseline to the our component, that is the distance traveled to the our component. If our RF value is greater, It's mean our component is non-polar. If our RF value is less, it's mean our component is polar. Due to RF factor, we determine our polarity of the compound. Now we use different types of paper chromatography, such as descending development or radial development. Descending means we our mobile phase is through this side, and we did a radical means we place a battery plate in which we place a mobile phase and cover it with this. After that, now we discuss about the thin layer chromatography.